Hello, my name is Deshaun.
Hi, my name is Tian.
Hi, I'm Rachel.
Hi, I'm Chris.
And we're teaching you about electron configuration. An electron is a stable subatomic particle with a charge of a negative electricity found in all atoms. Electron configuration is a statement describing the populations of electronic energy sublevels of an atom.
So the periodic table has 4 blocks. The S block, the P block, and the D block. Well, F block also, but we don't have that up here right now. Now, the S block, it has 1 orbital and 2 electrons. The P block has 3 orbitals and 6 electrons, while D block has 5 orbitals and 10 electrons. The F block has 7 orbitals and 14 electrons. Okay, for the base of electron configuration, first we have the period. The period is the certain rows on the periodic table, such as period 1, so every element in row 1 is part of period 1.
Which is the first space in electron configuration. The next space is
Blocks. Blocks are things such as block S, block D, block P, and block F, which we don't have up here right now. The third thing is the counts. The counts is when you find a period, the counts is the amount of elements you count over in a certain block.
So if you are going to 2s2,
If you were to go to 2s2, you would go to period 2, you'd go to the S block and count over 2 elements.
and that would be beryllium. Example number 1, if you were to go to fluorine, first you would start out with period 1, and as you count, you would go down. So to start out, you would count 1s1, then 1s2, but that's the end of the period and the block. So your first answer would be 1s2. Then you would go down and you would count over in the S block in period 2. So you would count 2s1, then 2s2. But there's only 2 electrons in S block, so you would only count up to 2s2 for the S block. So that is your next answer. And finally, you'd go over to the P block and you would try to find fluorine, which is right here. And you would count over 5 spaces, 2p1, 2p2, 2p3, 2p4, and 2p5. And your answer is right here, F, 2p5. So in total, your whole answer is 1s2, 2s2, and 2p5. Example number 2 is oxygen. So when you start out, you would once again do the same thing. Go to the first period and count down. So the first period, you go to S block, 1s1, 1s2. It's the end of the block. So your first answer is 1s2. The next period is period 2. So you would go to the S block and count over 2 spaces, 2s1, 2s2. Then, finally, you would go to the P block because oxygen lies in the P block, and you would count 2p1, 2p2, 2p3, and 2p4. So your total answer is 1s2, 2s2, and 2p4.
Go.
Last but not least, the third example is palladium. Once again, you go through the period and you go down. So you start out with S block in period 1, 1s1, 1s2. So your first answer is 1s2. Next, you go down to period 2. The first block is S, so 2s1 and 2s2. So your next answer is going to be 2s2. You would go over to the P block, 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6. So your answer for that is going to be 2p6. You would go down to the third period, and you would go over to the S block. And the first you go over 3s1 and 3s2. So your next answer after again. 3P1, 3P2, 3P3, 3P4, 3P5, and 3P6. So your next answer is going to be 3P6. You would go over to the fourth period. The first is potassium, so 4s1, 4s2. Your next answer, 4s2. Then you would go to the D block. And remember, the D block is slower, so you're going to go down a period. So instead of being the fourth period, it's going to be period 3. So it's going to be 3D1, 3D2, 3D3, 3D4, 3D5, 3D6, 3D7, 3D8, 3D9, and 3D10. So that would lead to your next answer, 3D10. Then you would go over to the P block once again. 4P1, 4P2, 4P3, 4P4, 4P5, and 4P6. Your next answer is 4P6. Then you would go down and you would go over to the S block, 5S1 and 5S2. Okay, next answer is going to be 5S2. Then you would go over to the D block, and remember, it's slower, so it would be the fourth period, 4D1, 4D2, 4D3, 44, 45, 4D6, 47, 48. Final answer would be 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, and 4D8, palladium. And a quicker way you can do this is, the S block only has 2, so you can remember 1S2, 2S2. The P block has 6, so 2P6, 3S2, 3P6, 4S2. The D block only has 10, so you go down the period and you can count over 10. 3D10, 4P6, 5S2, and 4D8. And that is your final answer.
Alright, noble gas configuration is a shortcut over electron configuration. Like for boron, you would put helium in brackets because it's its preceding noble gas. And then you would go 2s1, 2s2. Since 2s2 is the final one in the block, that would be your answer. And then 2p1 from the p block. Also, we'll use one from farther down. For bromine, you would use argon in brackets since it's its preceding noble gas. You go 4s1, 4s2. That would be your answer for the S block. And then you would go all the way past all of this to 3d10 since its D block is slower. 4p1, 4p2, 4p3, 4p4, 4p5 would be your final answer for the noble gas configuration for bromine.
2, 3.
In the periodic table, there are 4 blocks. The S block, the P block, the D block, and the F block, which we're not including on this table right here. And there are periods that go from left to right. And
Which is the first space. The next space is the block, which are
the S block, D block, P block, and the F block, which is not here right now.
and the next space is the counts. For example,
Let's take carbon, for example. You would count left to right, 1s1, 1s2, then 2s1, 2s2, then in P, 2p1, 2p1, 2p2,